Okay, this is verifying trig identities. I've given everyone in class a packet of formula sheets that start on 5.1 and go all the way to the end of the year, so 6.6. So don't throw this packet away, you're going to need it for the rest of the year. And we're going to start using it today. The first thing you should know is that there are these things called identities, and that's this on the first page. Essentially what these do is allow us to express a value or a quantity in just another way. So if I ever wanted to say sine over cosine, I could simply take that away and write the word tangent. Or if I had 1 over cosine, I could take that away and write that as secant. So basically these are simply expressions that can be exchanged for other expressions on the other side of the equal sign. So one of the basic ones are called Pythagorean identities, and these can be derived from the basic Pythagorean identity. Now, if it's written here, sine squared plus cosine squared equals 1, notice that the square is between the sine or cosine and the x. It's supposed to be there. You can't put it on the other side of the x or it would be wrong. Now, there are a couple other identities that flow from here. Basically, if you take all of these terms, and there are 3 of them, and divide them by sine squared x, what happens is this. This turns into 1 because it's a number divided by itself. Cosine over sine is cotangent, and if it's squared, that's just cotangent squared. And then 1 over sine squared is cosecant. So if it's 1 over sine is cosecant, so 1 over sine squared would be cosecant squared. So you can see that what I've just come up with is this identity from here. So I started with this identity and I ended up with this one. Now the rest of these in the list are simply rearranging the terms from the main one. So here's this one, I rearranged the terms and got 2 more, and then here's the one that I derived, and then I could rearrange those terms and get 2 more. And now I'm going to show you how to find that one. It's pretty easy. You just take the original one that we started with, and this time if we simply divide by cosine squared on each of our 3 terms, sine squared over cosine squared is tangent squared. The second term is obviously a 1. And then 1 over cosine is secant, so 1 over cosine squared is secant squared. So you can see that that is the second main Pythagorean identity. Now these 2 are a little backwards, but it doesn't really matter. It's the same thing as this. Okay? Now, like I said, these identities can be used to simplify things. You take one piece out, put a different one in, and now when you're verifying, you basically want to show that 2 things are the same, they're equal. One of the best ways to do that is just to turn everything into sine and cosine. So there are no sines or cosines here, but I can find things that are like that. Let's see, cosecant. Cosecant right here is defined as 1 over sine of x. So I'm going to take that and put it in replacement there. Tangent, you have a couple options with tangent. The most obvious one would be this one, sine over cosine. There's also this one, 1 over cotangent, but that's used a lot less often. So I'm going to go ahead and use this one, sine over cosine. And then secant. Secant is 1 over cosine. Now, you can see on this side that the sines are going to cancel, and you get 1 over cosine here. Now, you could just say, hey, 1 over cosine equals 1 over cosine, or you could say secant x equals secant x. As long as on the last line you have the same thing on both sides, it doesn't really matter. So you can see that I didn't necessarily have to change this to 1 over cosine. I could have simply said, this is 1 over cosine, this is secant x, and then change this one to secant, and then they both ended up at secant. That's basically how you verify something. You end up with, you change, you replace, you change, you replace, and then you end up with the same thing on both sides. Okay. Now again, I'm going to use the same technique as I just did. I'm going to change everything to sine and cosine, which I would say works about 85% of the time. So cosine x cotangent is cosine over sine. Now, what do I do here? Well, what I'm going to do is I'm going to try to, this is cosine squared x if I multiply across the top here. What I'm going to try to do is I'm going to try to get rid of the fraction. Now, in order to do that, I'm going to use a technique whereby I multiply everything on both sides by something, and so I need the full equation to do this. Cosecant is 1 over sine. So you can see if I look at the entire equation, I've got fractions on two parts, and if I wanted to get rid of both of those fractions, all I'd have to do is multiply by that denominator, sine of x. So that's what I'm going to do. I'm going to multiply each one of these terms by sine of x. Now, here they'll cancel, and here they'll cancel, and I end up with cosine squared x plus sine squared x equals 1. Now, this is true. I know in the Pythagorean identities that sine squared x plus cosine squared x equals 1. So on this, I'm just going to say this side is just the number 1. So if 1 equals 1, then yes, I have just verified that identity.